Hello, this video will show you how to use the virtual rough mill to generate arbors and some tips and tricks that go along with it. So the first thing you need to do is tell it what bundle you want, what your lumber looks like, basically, the bundle that you want to pick. So click here. There might be some generated already that's 6.5 inches, 7 inches, but let's just create one. So you go to New. So we're going to create 20,000 board feet, 1 inch thick, 110 inches average length, and 7-inch average width, with standard deviations of 1.5 inches here for the width and 1/2 an inch for the length. And you can change these numbers as needed. So you click OK, and it's going to generate this file for you. And you can look at the boards. Like this board is about almost 110 inches. It's 8.25 inches long. You can look at these if you want to, or you can look at the bundle stats. Shows you the lengths that range from 108 inches to 111 inches, based on that standard deviation we told it we wanted. And here are your widths, which are mostly from 3.2 inches to 9.8 inches long, wide. And that's based on our average width of 7 inches and our standard deviation that we wanted, which was 1.5 inches. So now we have our bundle, which is this file called generated, the text which we just generated, and we're going to create our first arbor. So if you already have, if we can create a new one, start with a new one, we'll call it bundle, we'll write over the old one. Here you would enter the widths that you are interested in, so the fixed width. So let's say 1.5, 2.25. These will be the widths that you need. Put 3.25 inch in there. You can enter your required amounts, whether they'll then indicate whether they're square feet or lineal feet, board feet, or none means pieces. So just leave it at square feet there. And because our required amounts are the same for each width, then our required amount percentages are 25%, 25%, 25%, which is self-calculated here. It's important that you enter your saw curve, your arbor width, 31-inch arbor, saw curve 0.17, and the number of blades you have. So in this case, I put in 13. So when you click next, if you don't care about required amounts, you can check box here, ignore required amounts. And then if you want to go by value or yield, so if you choose value, it'll calculate the values for you. This one here, keep arbor, means use the same arbor, but maybe change the values if you chose value here. I'm going to keep it on yield, and then I'm going to click generate. So it's going to generate an arbor that closely matches my required amounts because I didn't check box this ignore required amounts. So over here I can just say that's good enough. And this is how the pockets look like. So it's 2.25 inch, 3.25 inch, 1.5 inch, 1.5 inch, 2 3/4, and so on. And this indicates how much that's being used, how much that pocket is being used. So the higher this bar, the more that pocket is used. Over here we have our, the yellow means that there's a danger of yield loss. At this width. So at 1.6 inches, there's danger 2.4 inches. But look, most of the actual widths that we have, there's nothing yellow on it, as you can tell. And that gap means from 7 to 7.5 inches, the solution would be the same, which is to rip a 3 1/4, 2 1/4, and an 1.5 inches. Sorry, I was going like this, but it's 2 3/4, 1.5 inches, and 2 1/4. Like if I'm looking at this row corresponding to the 7-inch wide material, that's how it's going to rip it. And we click done. And this is what our arbor looks like and the arrangement. And that's it. We can save it. If you go back to this arbor, you can enter your offset spacing from the 0. And in this case, it's telling us we're using all 31 inches of that arbor except for 1.79 inches. Now there's other things you could do. You could go in here and say you have 3.5, 3.75 as well, but you really don't, you only want to rip one of these 3-inch pieces. So you could say these are optional. And then the program will pick the best ones that would match. So as a demonstration, here we go to generate. Say that's good enough. So in this case, it chose to keep those 3 different widths in there. Here's the 3 1/4, 3.5, and oh, yep, the 3.75 it left out. So that's how you can tell it that that width is not necessarily important for you if you're gluing up panels, for example. The other way to do it is you could tell it, instead of these settings, you can say 3 to 4 inches, anything in there, right? If I go here and I say anything between 3 and 4 inches, next, and then if you click generate, and then good enough, it will decide on the widths for you. So it chose 3 1/8 and 3 3/4. Right, so that if you're gluing up panels, this is one way to, and you have a fixed arbor, this is one way to see what widths would work best for you. And the program can calculate that. So again, the way you do that is I put in hyphen. That means anything from 3 inches to 4 inches you can use. You could even do it like this. If I see if this works. Anything between 2 4 inches, but you really need that 1.5 inches in there as well. So then you click next and then generate. And then the program figures out the best solid widths to put in your arbor. So it shows a 2 3/4, 3 7/8, 2 5/8, and looks like 2 7/8. So this is how you can get the program to choose your solid fixed width for you. Lastly, this select only if you have a select saw where it has a random, just one blade that is random, you can say that that's going to be where your select is going to be. And that's where you would check mark it. Or even a fixed length that can only be ripped on the select saw. But the most important things are make sure your kerf is correct and make sure your arbor width is there in a number of blades. Put in the widths you want. If you don't know if you're gluing up, you can put the hyphen here. Put in your solids that you need. If they're optional, that means you can do Without it, you can check these boxes and then click this generate button to see how it does. In this case, that yellow means between 3.8 inches and 4.8 inches. We could lose some yield there because the only solution is going to be to cut the 2.5 and the 2. That's it for the tutorial.